All right, class, this is the recording for section 11.2. I'm recording this out of precaution just in case I'm unable to do the lesson, and at least you have the recording. So here we have arithmetic sequences. And so I'm going to jump straight into what is an arithmetic sequence, which is what the gist of this lesson is. And so what I need you to understand is with an arithmetic sequence, the general formula is a sub n is equal to a sub 1, n minus 1, excuse me, plus the common difference. So we refer to this as the common difference. Now, what I need you to understand is that for it to be an arithmetic sequence, it has the same number sequence. So for example, if I do a sequence and I say to you, here are the first 4 terms of the sequence. What is the last term that you see here? Assuming this is a finite sequence. Obviously you can see the common difference if I take these and I say, well, what is 2 minus 4? Well, negative 2. It looks like the common difference is negative 2, and therefore that means that I have to subtract 2 from this 2 to find this number. So the next number should be negative 4. If I'm looking as an example 1, they're asking us to write the first 6 terms of the arithmetic sequence in which a sub 1 is equal to 6. And we're using the equation a sub n is equal to a sub n minus 1 minus 2. If you recall, we did discuss the recursive formula, and I said or referred to it as leapfrog. This is going to employ that strategy. So in this case, also remember that for it to be an arithmetic sequence, it has to be the same number of difference. So the common difference never changes, and it is a consistent shift in this particular example between values. So for example, we begin with a sub 1 since they want the first 6 terms. We know that's equal to 6. Here's a sub 2, which means that this is going to become basically 6 minus 2, which is equal to 4. The next term will be a sub 3, and in this case we know that this will be the equivalent of 4 minus 2, which is going to give us 2. A sub 4. Oh, and also remember that I stated you always start with 1 when they're asking you for the question stem, the number of terms in a sequence. So the next one should be 2 minus 2, which is going to give us 0. And then we have a sub 5, which should be 0 minus 2, which is going to leave us with negative 2. And lastly, here's a sub 6, which is going to leave us negative 2 minus 2, hence negative 4. And so this is the first example that they throw at you in this section. So you notice the sequence is consistent. The change is a drop of 2 units down. Same here, same here, same here. That's how you know it's a sequence. If not, it's just a pattern. So for it to be an arithmetic sequence, that has to be a characteristic. So the first 6 terms would be 6, 4, 2, then 0, then negative 2, and then negative 4. And these are the first 6 terms of the sequence. Now, I'm going to give you a try question. So I would like for you to try this. And if I say to you, write the first 6 terms of the arithmetic sequence in which a sub 1 is 100. And they also tell us that a sub n is equal to a sub n minus 1 minus 30. All right, so go ahead and do that one. I'm going to give you the solutions so you can check your work. So we have 100, then 70, then 40, then 10, then negative 20, and then negative 50. All right, so give that a chance. Go ahead and do the math, show your work, keyword, and therefore I'll give you a few seconds if you need on the clock, and then we'll move on to the next example. All right. So the next example, or the next concept that we're going to talk about, is example 2, which is using the formula for the general term of an arithmetic sequence. And so what they're giving us here is a question where it says find the 8th term. So find the 8th term of the arithmetic sequence whose first term is 4 and whose common difference is negative 7. So that's your question stem for example 2. And so we begin with what we do know, because we know quite a few things here. We know things. First of all, we're finding the 8th term. We know that the first term of this is 4. We also know that this common difference is negative 7. And we begin by saying, in this case, a sub n, which in this case a sub 8, is going to be equal to that first term plus, since n is 8, this will be 8 minus 1 times negative 7. So let me parallel some consistencies here. So remember that this is a sub n equals a sub 1 plus n minus 1 times the common difference. Well, the common difference, that's d, that's given to you here. And so this is our d, our 7, basically. Our n is, in this case, the 8th term, since they want the 8th term, and a sub 1, that's our first term, that's the 4. And all we're doing is throwing this into the equation. Okay, and just follow this as well, because this is important, because this kind of is informational. So now we solve for this equation up above, and we have a sub 8 is equal to 4 times 7 times negative 7. That's going to give you negative 49 plus 4, which is negative 45. So the 8th term is negative 45. Okay, so that is the notes for this part, example 2. Let me actually give you a try. So we'll call this the try of example 2. I'm going to write it just above. And so this try is telling me the first term in this example is going to be 6. So we're going to change this to a 6, whose common difference is going to be negative 5. And in this case, we want to find the 9th term. Not the 8th term, the 9th term. So that's the only change that we have in this particular set of examples. So go ahead and try this. This is the try for example 2. I'll give you a minute to write it down, a couple seconds. You can always pause the video because I'm providing you the video. So for the sake of the example, and just go ahead and try it. Okay, and I'm going to go ahead and move on to example 3. And by the way, the solution for this second part should be negative 34 when you get there. All right, example 3. Let's talk about example 3. Here, we're going to use the formula for the general term of an arithmetic sequence. So we are using the formula for the general term of an arithmetic sequence. Okay. So we have, as the question, it actually says write a formula for the general term or the nth term of the arithmetic sequence. All right, and here we have negative 2, comma 8, comma 18, comma 28. So the first thing you should be thinking is, what is the common difference? What do we know? So I know that a sub n, or in this case, a sub 1, because the first term is a sub 1, let's just call it a sub 1, is 2. We know that. We also know that if I look for the common difference, that is going to be equivalent to 8 minus 2. So it looks like this is 10. So if I go from here to here, I jump 10 units. And if I go from 8 to 18, I've jumped 10 units. And if I go from 10 to 28, I've jumped 10 units. So it looks like 10 is our common difference. Using this information, I'm going to go back to my basics and I'm going to say, okay, well then a sub n is equal to a sub 1 plus n minus 1 times that common difference. So a sub n is equal to that negative 2. And this is plus, I don't know the nth value they're asking, but I do know that this is times 10. So notice in this one, we're actually just going to write a formula. If I'm writing a formula, I have to be missing at least a variable. So a sub n is going to be equal to -2 plus 10n minus 10. Collect like terms. My final answer will be a sub n is equal to 10n minus 12. Okay, remember, we always write the variable first, because this is technically power-wise an n to the 1, and this is technically n to the 0. And we always write these in numerical order, so that has to go first. All right, so same question stem. I'm going to give you a try, and I'm going to just simply change these numbers here. So we are giving you -4, 2, 8, and 14. And you are in essence, and this is the try part of example 3. So once again, apply this formula, and let's see what values you come up with. I'll give you a few minutes on that. And just for the record, it should be a sub n is equal to 6n minus 10. All right, I am skipping example 4 because it's an application question, and you guys will get plenty of practice on that in your homework. And it's just using the same formula, so I'm not going to do this because it requires a little bit of drawing, and you guys can do it. And we can always talk about it during office hours or during class, your choice. So there is a set of formulas next that I need to talk to you about. And the concept or the formula is, if I have S sub n is equal to n over 2 times a sub 1 plus a sub n. All right, and so this is the sum of the first n terms. This is how we find the sum of the first n terms of an arithmetic sequence. And by the way, the only reason I've been able to record today is because I have absolutely no students in tutoring. So here we are. This brings us to example 5. And going back to the formula just in case you missed it. Example 5 is asking us as a question stem to find the sum of the first 100 terms of the arithmetic sequence and so 1, 3, 5, 7. And so this is what we have. And given this information, we're going to look up our formula. Since I need to find the first 100 terms, the sum of the first 100 terms, I'm looking S sub 100. So that means that n is equal to 100 based on this example, which means that this is really 100 divided by 2 times, and since they're giving us the first term as 1 plus, and then the last term, a sub 100, which we don't know yet, if we apply our formula, we need to find this. So we go back to our original formula and we say, okay, then a sub 100 is equal to 1 plus the 100 minus 1. The common difference looks like it's a plus 2 because I go plus 2 on every one of those. So that times 2. And that means that my a sub 100 is 199. So I'll put 199 here. And now using that, that tells me that this is 50, which is what I get here, 50 times 200, and that's equal to 10,000. So my S sub 100, the sum of the first 100 terms comes to 10,000, given that starting sequence. Don't forget that this actually ends with dot, dot, dot. All right, if you would like another question like this to try, I'm going to do this in class. This time they just want the first 15 terms, the sum of the first 15 terms. And instead of these values, they're giving us 3, 6, 9, and 12, dot, dot, dot. So go ahead and apply the formula and see if you could find using the steps. So if you notice that we have to take a little pause and we have to calculate that before we continue. Once we found it, then we went back and we continued the process and finished. All right, I have 2 more examples to cover with you and then we're done for the day. So let me do example 6 with you. So this is using S sub n to evaluate a summation following, or so the question is actually find the following sum where we have the 25 endpoint, the sum starting at 1, given 5i minus 9, which is a lot of work to do. So you can go ahead and use the system I showed you last time where we would start with, for example, 5 times 1 minus 9 and get that value, plus, and then 5 times 2 minus 9, and then continue, dot, 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 all the way to 5 times 25 minus 9. Okay, you can do that. Knock a little heart out. Enjoy. And eventually, when you add them all up, all 25 of those values, because remember that continues all the way to 25, you should get 1400. I'll see you tomorrow if you'd like to try that. Or we could use our formula, S sub n is equal to n over 2 times a sub 1 plus a sub n. So first things first, we would need to find a sub 25. So a sub 25 is equal to that a sub 1 plus that n minus 1 times the common difference. All right, so a little bit of math. I know that when we start with the first value, this should actually equal -4, and we need that. We might also even need this to establish a common difference, which is +1. So that does help a little bit. And in doing so, or the other thing we could do is we could just find a sub 100, which is this one here. which if we do that math, we should get 116. So technically, I don't even need to do this already. I could skip that part. Okay, so if that's the case, then that means that we have S sub 25 is equal to 25 over 2 times -4 plus 116, which is going to give us 25 over 2 times 112, and I believe that will render us 1400 as a final answer. And that will take us a lot less time than if we do it the long way. Just saying. If you want to try one for practice, let's do this one. It's the same question stem as this. I'm just going to change this to 30 with the summation starting at I is equal to 1, given the formula 6i minus 11. Remember, I showed you how to do that in Excel as well, but you won't have Excel during your test. Okay, example 7 is another word problem dealing with the formula. They do give you a starting point in this question. I guess this will vary based on the type of question you have. So I think this is one that you should perhaps just focus on in the homework. It's pretty much substitution. It's, believe me, if it required any brain power, I'd walk you through to make sure you got it. But you guys are brainiacs. This will be super easy. I know it will be. I don't want to insult your intelligence is what I'm getting at. All right. Hopefully this recorded well. Here we go.